I gather up a few 1x4s and a couple of pre-cut half-inch cornhole tops that already have the holes cut in them. These boards are exactly 48 inches by 24 inches. These boards have a red oak veneer top and have a really nice grain pattern. I now start to measure the 1x4s to make the frame. I mark the smaller front and back pieces at 2 feet. I carry the marked boards to the chop saw and cut 4 of them, 2 for each board. I now mark the boards at a long 46.5 inches for the longer sides. I mark each board and I carry the pieces over to the chop saw and cut 4 of them. I now begin to assemble all the pieces onto the bottom of each board to make the frames. I apply wood glue to each corner and nail them together using 2-inch brad nails. After gluing and nailing down each corner, I then apply wood glue to the top of the frame. It's better to apply too much glue than not enough. Just make sure you clean up any excess glue with a damp cloth. I now position the cornhole top onto the frame. I align it and make sure it's flush and square to the frame. Once satisfied, I clamp it down and nail it to the frame with 2-inch brad nails. I flip the board over and decide to install cornhole cubbies underneath. I measure the center of the long side, which is exactly 2 feet, and I make a mark. I then place a cornhole bag to the center of that mark. Next, I take a quick measurement of the cornhole bag and decide that 6 inches is slightly larger than the bag. I then center the 6 inches on the center mark and measure out 3 inches on either side, and I make my marks. I then measure and cut 2 1x4s to fit inside the box, and I place them at the mark. I then test fit the bag between the boards and it fits perfectly. I remove the boards and grab a flat piece of 1/8 inch material that I will use as the door. I position the board about 3/8 inch from the top of the 1x4 and I mark both sides of the 1/8 inch material. I adjusted my table saw to those marks and made 2 passes to cut in a long slot on the top of that board. After the second cut, I test fitted the 1/8 inch board in that slot and it fit great. Since I will eventually attach an Arduino to control the lights on this board, I wanted to cut in some notches so that I could easily run wires to the bottom of these boards. Here's a quick example of how the notches are going to work and how you can easily run wires from one side to the other side. I now went to my laser cutter and cut and engraved a door out of 1/8 inch acrylic. Here's a time lapse of the cubby installation. I use glue and 2-inch brad nails for this. Having a cubby underneath your board is a great way to store your bags and other small items. It doesn't take that long to add this feature to your board, so give it a try. I guarantee you'll be glad you did. So here's my finished storage cubby. The doors slide easily from side to side, and I now have a permanent place to store my bags. I get a 16-inch piece of 1x4 and I place it on the back side of the board over the hole. I screw it into the back using screws that are short enough that they don't pop out the top surface. This piece is going to be a jig to help find the center of the hole for the circle jig. I next find a piece of 1/2 inch material and I tack it to the 1x4. This piece will be flush with the top surface. I then measure in from the side 12 inches and I make 2 marks. I then connect the marks to form a line. I now measure down from the top center 9 inches to make 2 marks. I connect the marks to form another line. Where the lines intersect is the center of the hole. I now measure in from the side 12 inches and mark the bottom of the hole. I measure up 8 inches from the bottom of the board and make marks on both sides. I now connect the bottom marks on both sides to form my V-shaped pattern. I now measure out 3/4 of an inch from the V line and I make my marks. I do this on both sides of the V line. Once done, I connect my marks to make a line. I now measure in 3/4 of an inch from the sides and I make my marks. I then connect my marks. I now measure in 3/4 of an inch from that line and I connect my marks all the way around. I now measure out from two sides of the hole 3/4 of an inch. I adjust my compass and I make an outer circle to the hole. I am now done mapping out all the 3/4 inch channels that I will route out. I drill an 1/8 inch hole in the center of the circle and I attach the centering piece for the router's circle jig. I'll be using a 3/4 inch straight bit on my router. Here's a cross section of the 1/2 inch plywood. It has 3 layers of fill material as well as the top and bottom veneer surfaces. Now here's a cross section of the thin LED strip that I'm going to use. I'm going to want to rest the LED strip about 3/8 of an inch into the plywood, going into the 3rd layer just a tad. I adjust my router to plunge into that depth, 3/8 of an inch. I attach my plunge router onto the circle jig and verify that the bit is lined up with the circle that I marked earlier. I check my alignment around the circle before making my first cut. I now plunge in halfway and slowly route out the 3/4 inch circle. I blow off the sawdust and I plunge in the rest of the way and slowly make my second cut to depth. I remove the router and jig and clean up a few areas. Apparently the jig was a micro-inch off. I now set up my fence for the long straight cuts. I double and triple check that the bit is lined up with the lines from top to bottom. I begin making my cuts as before, plunging in halfway on the first cut, followed by a second plunge cut at full depth. Make sure to take your time and always make sure your fence is solidly clamped. I'm now done with the hardest part of this build, and I'm really pleased with the way they're looking so far. I attach a roundover bit to my router and I begin to round over the edges on the top surface of both boards. I remove the centering jigs from both pieces and I'm ready for the next step. I place the LED ring over the hole and notice it does not lay flat because the wires are underneath it. So I flip the ring over and I place it flat on the bottom surface. I mark the inside and the outside of the ring, and I also mark the general area where the wires are. I connect my marks and determine the area where I have to remove material. I attach a 1/4 inch straight bit to my router and I slowly plunge down to make the pass-through hole for the wires. I grab the light ring and I feed the wires through the hole and test fit the LED ring. It fits nice and flat with the wires now going underneath the board. I marked the location for the next pass-through hole because I will be using 2 more LED strips on this build. I will cut off the end connector and solder 3-foot lengths of red, green, and white wires that I will feed through the hole later. Using the same 1/4 inch bit, I plunge down and make the second pass-through hole for the wires. Earlier I soldered the red, green, and white 22 gauge wire to both strips. I fed the wires from the LED strips through the hole and made sure to test fit both of them before proceeding. Resin is a very tricky medium to use, and avoiding bubbles is always a challenge, so I always test my resin to the current plywood I'm using. I flip the board over and I route in a few test pockets that are the same thickness as the channels on the top surface. I decided to use the resin that I used in my last project. I apply a different combination of wood sealer products to 2 of the pockets, but I leave 1 pocket bare as my control. I mix up a small amount of resin for this test. This resin has a work time of 12 minutes and totally cures in about 3 hours. I fill each pocket with resin and I wait for the results. Here's the time lapse of the cure, and one word describes the results: crap. There were a massive amount of bubbles in each test pocket. The resin also rose above the surface. Since none of the results were acceptable, I will have to find and test another resin. The moral of this story is, never trust your last test results. If I would have used this resin on this project, I would have destroyed the project and I would have had to start over. I routed in more test pockets and labeled them accordingly to the wood sealer brands I applied, leaving one bare as my control. I decided to use Deep Core by Moss. I'm thinking that a longer cure time will allow the bubbles to not get trapped in the resin. So I mix up a small amount of 3:1 resin and I pour it into the test pockets. 3 of the pockets have a combination of sealers and 1 is bare wood. I now wait 36 hours for the result. After 36 hours, the results were amazing. The resin was rock solid and there were no bubbles in any of the test pockets, not even the control. So I decided that the best results was the sand and sealer on the top surface, and this is the one I'm going to go with. So I brushed on sand and sealer to the entire top surface and allowed it to dry completely before going on to the next step. I feed the first LED strip into the top pass-through hole. I count out the number of LEDs it takes to get to the first turn. I cut the strip on the long side of the soldering pad, leaving as much of the soldering pad as possible. This will make soldering easier later on. I sacrifice the next LED and cut it off, leaving the entire soldering pad. I position the strip at the turn and tape it down and roll it out till the next turn. I cut the strip again and continue laying the LED strip up the channel. Be very aware to keep the arrows on the strip going in the same direction. This is the direction of the data. If the arrow goes in the opposite direction, it will not work. Continue laying down the LEDs till you get to the top of the strip and cut it at that point. The LED light ring will lay on top of the strip. Now remove the adhesive backing off the strip and stick it down. Do this to the remaining cut pieces. Now that this is done, let's connect our strips electrically. Solder small pieces of 22 gauge wire from 5 volts to 5 volts, data to data, and ground to ground. This step is easier if you tin your soldering pads beforehand. Continue to solder your strips together at each turn, 2 turns on each side. When done, connect each strip to a 5 volt USB hub and ensure that they light up. If not, you made a wiring mistake. Right strip, good. Left strip, good. Working great. The other board tested good as well. Cut a piece of thin, pliable plexiglass that is the circumference of the hole. Using packing tape, place the plexi onto the tape and form a circle by butting up the other end and pressing it into the tape. Fold the tape over and tape the ends together. Now place the plexi circle into the hole. It should be a tight fit. Now ensure that the plexi circle is flush with the bottom of the plywood. This plexi circle will act as a dam and prevent the resin from leaking into the hole onto the floor. But first we have to seal the seam. Place a bead of silicone between the plexi and the bottom of the plywood. Using a wet finger, push the silicone into the crevice. Run another bead of silicone around the rest of the circle and press it into the crevice using a wet finger. Now that we're done sealing that area, let's seal the hole. Apply silicone into the hole, pushing it into and around all the wires. Once done, flip the board over and apply silicone into the hole from the bottom side. Once done, flip the board over and allow the silicone to dry. After allowing the silicone to thoroughly dry, place the LED ring over the dam and center it over the hole. Connect the ring to a 5 volt power supply and test it. Test now before it's embedded in resin. I glue down the light ring on the board using UV resin. I tack it down in 4 spots to ensure it can't move from the center. Now there's one more area to seal. That's where the ring light wires go through the hole. Now let's apply a bead of silicone to that area, then push it into the hole with a wet finger. Now flip the board over and apply silicone to the hole from the bottom side, making sure to push the silicone into the hole and between the wires. Allow the silicone to dry before proceeding. The most important thing to do before pouring the resin is to make sure your boards are level in all directions. Resin is a liquid and will self-level. If the surface is not level, the resin will find the low spot and overflow onto the top surface. I used a number of shims all the way around my board to ensure that it was level. I mixed up 12 ounces of 3:1 resin. This will be for the first pour. It will be just enough to cover the LEDs. After it cures, I will make another batch of resin and do a second pour. After mixing for about 3 minutes, I added a small amount of silver pearl pigment. This will be used so that the resin will have a slight tint, so that I can see the surface of the resin when poured. It's easier to see the surface than if it was clear. Slowly pour the resin into the channel, allowing the resin to flow and self-level. Take your time and pour slowly and deliberately. This resin has a work time of 3 hours, so no need to be in a hurry. If you noticed, I'm pouring the resin in my house rather than the garage. The garage temperature was over 90 degrees. This resin has to be poured in temperatures of 65 to 75 degrees. After this pour, I let the resin cure for 36 hours. This is a close-up look of the cured resin, and with the slight tint, you can see the resin is slightly over the LEDs. I mix up 16 ounces of resin for the second pour, and I add 5 times the amount of pigment than I did the first time. After stirring for about 4 minutes, I begin to pour the resin into the channel. I always allow the resin to self-level and just flow to where it wants to go. My intent is to not immediately fill the channel to the top surface. I just want to pour enough resin to completely fill the entire channel to where it's just below the surface of the board. Now that I've poured the entire channel to just below the surface, I now come back and start to fill the resin to be level with the top surface of the board. After about 5 hours, the resin is thickened enough that I can begin to swirl in some patterns into the silver pearl pigment. These patterns will catch the light and give it a great look. I now let the resin cure for 36 hours. After 36 hours, the resin dried rock hard and it looks amazing. I now remove the plexiglass dam. After completely removing the dam, I grab some 60 grit sandpaper to remove the sharp edges off the circle. I continue sanding, moving up and finishing at 120 grit. I quickly cut and attach the legs to both boards. This LED resin project is done. All we have to do is connect the lights to power. In my next video, I will connect the LED strips to an Arduino Nano and program the Arduino to control each one of my LED strips individually. But I will quickly show you how to connect these strips if you want to use them as is with the built-in microcontroller. Gather up and feed your wires from the LEDs to the bottom of the board or wherever you're going to have your power. You could even house them in the cubby. Connect the red, white, and green wires from the LED strip to the red, white, and green wires on the controller. Next, connect the other end of the controller to a USB cable. Use the black and red wires from the USB cable. That will provide the 5 volts. Now do the same for the other 2 strips. Now using a rechargeable power supply and a USB 3-way splitter, connect the splitter to the power supply and connect each LED strip to the splitter. Now turn on the power and enjoy your LED cornhole boards. Well guys, this wraps up another video. I hope you enjoyed it. Please like and subscribe and join me on my next video where I make this into an electronic cornhole board by programming an Arduino to control sensors, lights, and buzzers. I hope you have a great day. See you soon and God bless.